Today, we're talking about a disease that's been around for centuries, but is still a massive, fast-moving threat all over the world: cholera. It's a really powerful reminder of just how deeply our health is tied to things like clean water and infrastructure.
All right, here's how we're going to break this down. First, we'll get a real sense of the threat itself. Then, we'll follow the path of how it spreads, see how labs actually confirm it's cholera, and then get into the race against time to treat it. And finally, we'll look at the big picture, how we can build a lasting defense.
So first things first, let's just try to get a handle on how serious cholera really is. It's the sheer speed at which it can take over a person or even a whole community that makes it so incredibly dangerous. Yeah, look at that number. The World Health Organization estimates that up to 143,000 people die from cholera every single year. This isn't some ancient disease we read about in history books. It's happening right now. And it's just a brutal reminder of the human cost of a disease we know how to prevent. So what is cholera exactly? Well, it's a nasty infection you get from swallowing food or water that's been contaminated with a bacterium called Vibrio cholera. The main symptom is really severe watery diarrhea. And that's what's so dangerous, because it leads to dehydration so fast that it can literally be fatal in just a matter of hours if you don't treat it. Okay, so how does this little bacteria manage to spread so effectively through a population? Understanding its journey is absolutely key to stopping it in its tracks. The number one thing to get here is that cholera spreads through contaminated food and, way more often, contaminated water. It absolutely thrives in places that don't have good water treatment, proper sanitation, or basic hygiene facilities. You'll hear public health folks call this WASH. And this is exactly why outbreaks can be so explosive. Just think about the devastating outbreak in Haiti after the 2010 earthquake completely wrecked our sanitation systems. It's a tragic, real-world example of how a breakdown in basic infrastructure can just unleash this disease on people. Now let's switch gears. Let's say a patient shows up with severe diarrhea in a place where cholera is a known risk. How do doctors go from just a suspicion to a confirmed diagnosis? This step is critical, not just for the patient, but for tracking a potential outbreak. It all starts with getting a good sample. You need a fresh stool specimen or a rectal swab. And here's the crucial part. You have to get it before giving the patient any antibiotics. Why? Because the drugs could kill the bacteria, and then you'd never get a positive result in the lab. The sample then goes into a special transport medium, something like Carrie Blair, to keep the bacteria alive on its trip to the lab. And this is the aha moment. This is what it looks like in the lab. They spread the sample on this special agar plate called TCBS. The Vibrio cholerae bacteria grow into these very distinct, kind of translucent-looking colonies. This is the visual proof scientists need to say, yep, it's cholera, and sound the alarm for public health officials. Okay, so a diagnosis is confirmed, or maybe just strongly suspected. Now what? The response has to be immediate. With cholera, you are literally in a race against time. Now, what's so amazing here is that our most powerful weapon against cholera is incredibly simple. For the majority of cases, all you need is oral rehydration solution, which is basically just a precise mix of clean water, salt, and sugar. That's it. It's enough to replace the fluids and electrolytes the body is losing and, quite literally, save a person's life. But of course, for patients who are so dehydrated they can't even drink, you have to be much more aggressive. That's when intravenous fluids, an IV drip, are absolutely essential to rehydrate them fast. Doctors will also use antibiotics, which help kill the bacteria, shorten how long the person is sick, and reduce the amount of diarrhea. And this chart is fascinating. Look at how targeted the antibiotic treatment is. For most adults, it's just a single dose of doxycycline. For pregnant women and kids, it's azithromycin. This single-dose approach is a game changer because it's so effective for treating huge numbers of people really quickly in the middle of a chaotic outbreak. So treating sick people is obviously critical, but the real goal, the ultimate goal, is to stop cholera from ever getting a foothold in the first place. How do we do that? How do we build a defense that actually lasts? Well, you can think of it as a two-pronged approach. On one side, you've got the reactive treatments we just talked about, the rehydration solutions and antibiotics you use once someone's already sick. But on the other side, and way more powerful in the long run, are all the proactive things we can do to prevent it.
When you boil it all down, a world without cholera is totally possible. It just requires investing in the basics: safe drinking water, decent sanitation systems, and hygiene education. And alongside those big infrastructure projects, we have another great tool: the oral cholera vaccine, or OCV, which can be used to control outbreaks that are already happening and to protect communities that are at higher risk.
And this brings us to the final, really tough question. We have the science, we have the tools, everything from simple sugar salt water to effective vaccines. So why? Why does this disease still kill so many people? It's a question that forces us to look beyond the microscope and into the much more complicated worlds of economics, politics, and global inequality. Thanks so much for joining this explainer.